Hello and welcome to the second webinar for the BACnet SC Interoperability Acceleration Program. I'm Andy McMillan and I'll introduce here and moderate for a few minutes. Let me start by talking about our program objectives. Right, for this overall interoperability acceleration program, there are a couple of things we're trying to accomplish. One is to speed up the availability and acceptance of BACnet SC in the community, and to accelerate interoperability among BACnet SC devices. And the third thing we want to accomplish is to support the test labs with products for test networks. Since our first webinar a little while back, you've noticed that we've released both a beta 1 and a beta 2. And along the way, you may have figured out that those releases actually contain more than just a reference implementation. Along with the source code for a reference, there's also a collection of 7 pre-configured tools that will help you understand BACnet SC systems, as well as test your own device in the context of those systems, and to do that at scale. Along with that, those tools are configurable and extensible to allow you to incorporate them in your own test environments. Along with the software, the program also includes a forum for discussion and questions and answers. If you haven't been there yet, you might want to do that. We're talking about implementation of devices and also deployment issues related to BACnet SC. We're also going to be developing some BACnet SC test capabilities and services, which as members of this program, you'll get a chance to take advantage of. I want to thank all of you for your participation. Industry collaboration is right in the DNA of the BACnet community because it's the fastest and the best approach to making collective progress on interoperability. This is your program, so let us know how it can best serve your needs. Our speaker today is Dave Robin. Of course, Dave is a longtime member of the SSPC 135, the development and maintenance organization for BACnet, including being a former chair of that group. He's an author of substantial parts of the spec and a member of the working group that created BACnet SC. In today's webinar, Dave's going to talk a bit about the particular software and the components that are in the beta 2 release. As the developer, he's going to give us some examples of how to use them and walk through some aspects of the extensibility associated with them. Now, David has prepared a lot of content for today, a lot of detail, and you'll get a chance to see some of that. But you might have questions either about the content or things that we didn't consider and therefore did not put in the content. Or you may come up with questions over the course of the webinar. Feel free to submit those questions using the Q&A icon on the bottom of your screen. If we can answer them in the webinar, we'll try to do that. But all the questions, including those that are not answered in the webinar, will be answered in the program forum at that URL on your screen sometime in the next few days. So if you haven't signed up for that, you might want to sign up right after this webinar. Finally, let me let you know that this webinar is being recorded. That will allow you to access it later. So you can go back and revisit sections at some future date if you want to. All right, with that, let me go forward with the content of the webinar and turn you over to Dave.
Okay. Let me share my screen and hopefully this will work. All right. Do you see me and do you hear me? Uh-oh, you don't hear me.
I do, Dave.
Oh, okay. Oh, there. Oh, yes. Very good. Sorry. Very nice. Okay. This, we're going to go through this pretty quickly. I had a clock up on my page, but to keep me on track. There we go. We got a lot to cover here, and I'm going to start out simple. We're going to dive deep into the weeds and get deep into what's Hopefully it doesn't feel like a programming tutorial. I know most people watching this are probably programmers. So by everything that I've chosen to introduce here is introducing a concept or part of the API of the toolkit, and introducing it sort of as a toolkit, show you how it's built and how you can extend it. And the main focus of this presentation is on extensibility of the toolkit. And as Andy mentioned, there's a bunch of pre-made applications that you can configure with text files to do your testing. But one is missing. And when we got close to doing beta 2, I said, oh my gosh, we never actually did an SC to SC router. And then I thought, well, that sounds like an excellent topic for a webinar. And so we're going to make an SC-SC router today, and with the intention of showing you how simple it is to do, so that if you want to make an SC to SC to IP to whatever router, you can. So this last piece, I think the SC to SC router will fit in nicely with all the other tools, and we'll see then how it plays well. We're going to create something. So we'll start out, this is our mission today. We're going to make this an SC-SC router. But by the end of the hour, we're actually going to make this, but that's really scary. So we're going to go back to this for now. So start a little bit at a time, and I'll show you how to actually end up with this, and we're going to test this, but we're going to get there a baby step at a time. So we start here. Obviously, first thing you would do is create a new class, test SC-SC, we'll call it. In any IDE, the distribution comes with a built-in support for IDEA, which is a fantastic one. It's free. Everything I'm doing is with the free version, so you'll love it if you haven't already used it. But you can use anything you want. So now every application in the system extends application. Now this application, that's the best documented class in the whole thing. If you want to know how all this works and you don't want to listen to me, just go to application.java and it'll explain all this stuff. And it talks about it reads the configuration file. Everything is driven by the configuration file. It creates the shell. It creates callbacks to you. And you'll see that an application that we're about to build is actually quite short and simple, because the application class itself does all the kind of the grunt work to get you up and going. So to start with, let's just copy all the contents of test router into our thing, because test router is similar. A router routes from IP to SC. So we want an SC to SC router. So let's look at how test router is constructed, and pretty much the whole thing is on the screen right now. You can see it has two data links, SC data link and an IP data link. And these are the callbacks I was talking about from application. You don't have to worry about a main. It loads the config file and everything, and then it simply calls start, stop. It even has one called close, which is like a panic stop, But you can see all we do here in the start method is we set some stuff up, and then we start our data links, and in the stop method, you stop the data links. So let's look at it. You start by creating a device. Now, this framework is designed, it doesn't assume a device. This framework can support multiple devices, and occasionally you'll see, as we go forward in this hour, you'll see the word device plopping around as an argument in methods. And that is because nothing is assumed that there is only one device. This test framework is designed to create multiple devices in one application. So this is going to create one device, but the others, like test combo, for example, if you go look at test combo, it creates multiple devices. And test nodes, of course, creates 1,000 devices and 1,000 nodes. So we're going to create one device in this router. So we create the device, and then you can see that we create the two data links and we assign it to the device. So now, this is an example of a test setup that we're going to get to, but we don't want to write code for all this. So all of this I want to be driven by properties files, and that's what we're doing here. So basically test SC, let's see, I got a mouse, here we go. Test SC, test router, all these green things are the little apps that come with the toolkit, but we're gonna make this test SC one over here. They're all driven by text files, and that's what the little purple annotation is here. So let's look at one of those. For example, the test router properties file has this IP network number and SC network number. It just has text. Great, well, how does that get in the code? So let's go back to our code of test router, and you can see that the test router pulls in these two numbers here through, gets it from the configuration. And again, you don't have to mess with reading in a config file. The application framework does that for you and just provides this member variable called configuration. And then you read in these special things in your application. So poof, all I did is take out IP, turn it into SC. Now we have SC1, SC2. We're done. Looks like we're done. We've got two data links, one device, starting both, stopping both, fired up. Nope. It would work kind of, but you have both your data links are operating off the exact same properties. So obviously that's not going to work. So we have to have some kind of difference between the two, important differences. So notice that for test router, that wasn't a problem because there was an IP properties section and an SC properties section. And so they both read their section out of the configuration file and they just worked. So there's no collision. But let's look at what SC properties actually does. The job of SC properties and IP properties as class files is to take all that text stuff from the configuration file and turn it into member variables, but regular accessible member variables, get them out of the text domain into the programming domain. So that's its job. Now, since we can't have two of the same, let's just lift them out. And so you see we create these two, we lift them out of the declaration of the SC data link, and now we can tweak number two. So we'll let number one work just as is, and we'll add configuration variables in our text file called app to SC primary hub, for example, and we're going to map that to SC properties to primary hub URI. So you can see these are the four things that we have to change for a second properties. For the purpose of this demo, just to make it work, these two SCs are sharing a certificate. They're sharing all the other settings, the max APDUs, all the other SC settings I didn't feel compelled to put in as app2 settings because then they can be, it's okay if they're shared for the purpose of our testing. But these four absolutely have to be overridden, the MAC, the primary hub URI, that kind of thing. And hub function enabled, you'll see in when we get to actually testing the thing, one of these I'm going to turn the hub on and the other one I'm going to turn the hub off just to show, flexibility of the implementation and the fact that decisions like that are all data driven, not code driven. So we're done. You just made an SC to SC router. Congratulations. Back to you, Andy. Seminar over.
Oh, Dave, that looks pretty easy to me, but there must be more coming.
Yes. So we did that. We did that part of the mission. But as we said, how do we know? We've got our code. We did our little SC to SC router, but how do we know it works? So ultimately, we've got to get in there and drop this SC to SC router into some sort of test environment. So let's go back to our little screen and say, okay, we've got this that we just built. Now, as I said, every SC data link in this toolkit, anyway, can be a hub. So you can turn it on or turn it off. So, but for our purposes, let's introduce another router, because one of the purposes of this exercise, when we announced what the webinar was about, one of the things I said is we want to make an SC to SC router and prove that the routing of secure path works, because that's a very important thing. When we get into authorization and other discussions later on, that secure path option is really important. You want to know that this message hopped between SC routers but never left. So we have to get an environment here in our testing where it can actually leave. So let's route over to IP. So we'll put in a router to IP and we'll move the hub just for fun. We'll move it from here to there so that the SC router is on one side of the SC router. It's a hub and a data link, and the other side, it's connecting to some other hub over there. Now let's make the opposite direction. We'll go from IP back to SC. So that's easy to do. And we have all the pieces we need now, since we just wrote test SC. So this is new. This green one's, the circled in orange is new. The rest of the pieces already existed. Obviously, test router already exists in the toolkit. Drop some devices in, of course. We got to have devices to talk. So these devices also exist in the toolkit. That's test node for the SC ones, and then test IP device. Didn't want to call it IP node because that's kind of confusing, but the others are test devices as well. Just their test SC device and test IP device, but these are the historical names. And because we can, on IP, I dropped in for the purpose of these demos and these tests and all the screenshots I did here in my office. I dropped in an actual IP router and a bunch of MSTP devices over there. So they'll show up when we do whois testing and read property testing and stuff. You can see actually routing from any one of those green devices back and forth to the blue physical devices on the other side of another router. So that's our test setup. And that looks reasonable. All the pieces are now available to us, and all of this is going to be driven by data. We're going to assemble all this without doing any code. So unfortunately, there's all the data we need. I mean, that's a lot, but you can't reduce it any farther. You need all of these numbers have to be assigned. And so I sat down to try and do this, and the first thing I realized is I need to write all this down. So it's either print this out and write on it, or do this. And so you've got the MAC addresses on there. You've got the hub URL addresses. This is shorthand. When you see .98, it's 192.168.1.98. So those IP addresses have been shortened. The MAC addresses for SC have also been shortened. They all start with 5 bytes of zeros. So that's the 00 ... nomenclature. So when you see in the and I would advise doing that in your own test setup. It just makes the logs easier to read. So test node number 1, there is MAC address number 1. So these are all the numbers we need. Now let's take this a little bit at a time and build this up, because we're going to launch a whole bunch of processes here. And each one is going to be driven by a configuration file. So we'll start with the easy one. Create a demo device properties file. And the only thing we have to assign here is pretty easy. We have to assign it the MAC address, the device ID 7770001, and the hub URL of 984443. So let's go do that. Device 1 properties, you can see it's based on test node. And we gave it a title. This is new. This is post beta 2, actually. I did this because I had a whole bunch of, when I'm doing this arrangement, I had too many of the same thing. I had 3 things called test node and 2 things called test router. And so I had to change the title on the little box that pops up. And so you can now set the title to anything you want. So I've set the title of this to device 1. You set the device instance, UUID, primary hub, VMAC. You can see the things you need. The rest of it you can leave as defaults. So let's do the complicated one. This is the SC router we just built. You can see that these are the things it needs. And in addition to the ones we did for the node, I'm calling this title SC-SC, you can see the primary, or the SC number 1 gets the SC dot whatever properties, like always, because having 2 of these is rare. So I didn't build in a tremendous amount of support for everything being duplicated. So if you have a second one, then you do something like we see on the screen, app.2.sc, and that's where you saw our code that copies these into the configuration for the second one. So that's it. We're done with that. Then test IP device. I'm not going to go through all of these, but this one is simple enough. It's an IP device, so it looks a little different. All you do is give them an IP address and a bind port. Pretty obvious. And then finally, and we're nearing the end of this, but you can see how we're building all this up just by editing the config files. Finally, these 2 are like mirror images of each other. So I'm going to just show that there's that one and that one and that one and back and forth. These things are like identical, but just all the numbers have been filled in to make it work according to our diagram. Okay, so we're done. We're done with that giant set, and you can actually fire it up and run all these things. That's 1, 2, 3, 4, 5, 6, 7 different processes, which would be 7 little boxes on the screen, and that's why it's important to give them names. So how do we test that this actually works? We want to test the SC-SC routing, and we want to make sure that authorization, the secure path, is properly passed around. And when I got to this point in my testing, I launched all this, and I ran manual commands for read property for some whois, find out who I was out there, make sure everybody's talking, do a whois all, make sure everybody's talking, and then set the target and did a read property. And because the read property just shows you the result, it doesn't actually show you the authorization. I looked in the logs to see, okay, yep, that authorization's coming through. So you can do read properties and you can look at the logs, and that's great, except that I had these 7 devices and I wanted to trace the SC path through all of these things. I wanted to follow from test node 1 to device 1 to device 2 to device 3 to device 4 and back and forth and see the routing. I didn't want to just stare at the logs for doing all that. Or I did for a while, but then I thought, oh, there's got to be a better way. I'm going to make a command, a new command that I can just run from somewhere that will do all this stuff for me and show me whether it was a secure path or not. Just make it real in my face. So let's get creative and build a command. So this is the next part. And this is going to seem like it's going to take a long time, part of this presentation. So it's probably, 15 minutes of the presentation or more is going to be about building a command. But in the process of building a command, we get to introduce all the different ways that things are put together. And this is where the toolkit becomes truly extensible, because there's a bunch of built-in commands, but we expect that because this is interactive, you're going to want to do exactly what we're going to do now and build these one-off commands that are not built in, but they just for some purpose. And what we're going to build is well, let me explain. These apps can have their own commands. So you notice in the list of commands down there, starting with inject, DCHB, all those other ones, those are ones that are universal to everything. But the test hubs app, for example, has commands that will allow you to bring the primary up, the primary down, the failover up, the failover down. So those are specific commands that only make sense for the test hubs app. So that one application. So we didn't include them in the BACnet commands, and well, you couldn't, because they're dealing with data structures that only exist. They're dealing with devices and hubs and stuff that only exist in this application. So these are specific commands that were added to this application. And you can see the pup command here, and this is how commands work. They have the 3 strings basically say that the first string is the name of the command. The second one is how you use it. In this case, it's just pup. And then the third one is a lengthier description, which can actually be the source of man files. And I'll explain that a little later. But it's very simple, but these are added to test hubs to be for that. So let's create a Wix command. So we have a WI command, and this is the source of the name. We have a WI command that's built into BACnet commands. In all devices have the whois command, so WI for short. And so you can just type WI space all and poof, you get a global whois and you get all the answers. So, but for our purposes, I wanted to do this read property and get an answer back and see whether it was a secure path or not. That's really the key of what I'm trying to do with this new command that I'm going to throw away after I'm done. Because this is just to test, does the secure pathing work? So instead of typing in a target and saying RPX, which is like, read property extended, show me the secure path option, I don't want to have to type in targets. I just say, look, I'm curious about all the paths to all the devices. So let's just do a global whois. And for all the global whois answers I get, I'm going to turn around and do read properties of all of those guys and get there. Well, we're just going to read the device object name, for something that we know is there in every device. And that'll just make it real simple. So we just type Wix and watch what happens. And that's where we're going to go. So ultimately, we just want to do Wix from all the devices and look at all the paths and see how they're different. And we'll get there. So, but let's walk through how to build a command. So all commands extend command, obviously. And commands really just have one mandatory, I guess you have to implement execute. It has to do something. And when execute returns true or false, and this is how it interacts with the shell. It returns false if it says, oh, I'm not done. I'm not done yet. There's more to come. Please don't prompt the user again. This is an ongoing command. It's not finished. And when the command is finished, it can call shell.command done and then the user gets prompt again, or the user can cancel it. And I'll talk more about that in a minute. But for now, because this is an ongoing thing based on broadcasts coming in and read properties and all that stuff, we're going to return false. We'll make a comment to that effect so we don't accidentally default. Starts out as false by default, but you want to return true when you make your own command if it's really done, because otherwise the prompt will just like hang there and wait for you. It's like, is this command finished or not? So return true if you're done, return false if you have ongoing stuff. And we definitely will have ongoing stuff with this. So let's document it, because part of the help system is saying what this is. So the command name is Wix. You can see the options here. Then the synopsis, which would include things, and we'll see this later, which will include things like command line arguments. Basically a synopsis in a Unix man file format. You have name, synopsis, and then details. And so that's what these three are. So name synopsis is basically the command line with all of its options, and then details is the long string that can be multiple strings, and it can go on and on and on forever. Some of the commands are actually quite long in their description there. And then finally, you notice there's an option there for hidden. If you want, you can make a command that is hidden from the list. And there's a couple of system commands that are built in that nobody knows about, that like when a terminal window closes, it sends itself a command, that kind of thing. And you don't want to show those in the list or the help system. So you can make hidden commands if you want. All right, now let's make a plan. We've got our execute method, and I just put this in to remind myself, here's what we're going to do. We're going to do a global whois, and then we're going to, for every answer we get back, we're going to do a read property. And when we get an answer from the read property, we're going to print out whether it was secure path or not. That's the mission, right? Okay, so we start out with who is client. It's a good place to start. Every service in the toolkit, there aren't many. There's reinitialize device and read property, and there's the mandatory services. There is read property multiple, but not a lot of extra stuff in there. No read range yet. But anyway, every one of them has a client functionality, and you create a client object in order to use them. And some of course, you all are BACnet experts, and you're all saying, wait a minute, whois is not a confirmed service. How can there be a whois client? Well, we all know that whois is really a confirmed service with multiple answers, is effectively what it is. That's how you want to use it. And so in this toolkit, I basically said, okay, we're going to pretend that it's a confirmed service with multiple answers. And so when you issue a whois client, you can see that instead of just one callback, you're going to get as many as come in, only the ones that match. And I'll get to that in a second. Okay, so we're going to create a whois client. And if you create a whois client here, it's going to give you one method, success. Now, it's going to call you back for every successful IM that matched your whois. So it doesn't call you back. It's a little smart. It doesn't call you back for all the IMs. It only calls you back for the IMs that matched your whois query. So it is like being a confirmed service, but it just has multiple successes. So in our success, we're going to want to do a read property client, because that's what we're going to do, right? So we'll say read property client. Let's go make a read property client. You notice it has two callbacks, obviously, because it really is a confirmed service. So it has the concept of failure. So it's going to do success or failure. And all we wanted to do is print out the answer. So there is the whole point of this exercise, the big blue arrow. When we get our read property back, we're going to print out the auth information, and we can see on our screen whether it was a secure path or not. Okay, now we can finish the read property client, and what you do is make a request, and for every binding, you can see that the whois client is going to call us back with the binding that it got, and so we're going to turn around into a read property on that binding, and with these arguments. And I won't go into the detail, but we're asking for the wildcard. You can see we're asking for wildcard, device, and the object name. Okay, so then we go to the whois request, and here's your example of where I'm seeing the word device. That's not a target. That's because this is a multi-device framework. That's the device you want to use. And in our case, there's only one, so we just called it device. And that's a global broadcast, obviously, for the whois. So we're done. Let's go test it. Okay. For those who are not familiar with the terminal system, you can type help and you get this, and you type list and you get a list of commands, and you go, wait a minute, I thought we just created a command called Wix. Where is it? It must be there. Run it. No, it's not there. Drat. Okay, quit. Let's go back. Okay, notice Wix is in gray. That's a clue that the IDE is trying to tell you nobody's using this anywhere, dummy. That's because the application framework doesn't make any assumptions about what commands you want. Not even the built-in ones. The application doesn't. So the applications add the commands with a callback. They add the commands that they want. So there's a collection, there's two collections of commands, BACnet commands and SC commands, and those are, we add them in bulk. But here we're going to add a new one that we just created. Now let's run it again. We go over and poof, Wix is in our list of commands. We run Wix and we get an answer. Great. And notice it's paused. It's not giving me a prompt yet until I hit enter to say I'm done. Cool. Now that was very kind of, that was a boring answer because it was just the one device and it heard its own whois and it read its own property. But notice auth is 1Y, and what that is, that's a shorthand to say that is secure path. That's option number 1, mandatory or must understand yes. So that's the nomenclature for showing options. I wanted it as brief as possible, but it's so 1Y is a good thing. 1Y says secure path. So let's go paste this thing into combo, which has more devices. Combo is like three or more devices in there, and let's get some better answers. And there's also a router, so we can pick up all those other ones too. And we do our Wix command and go, wait a minute, why is there only one answer? If we do whois, look at all these whoises. We obviously must have got these. Let's do Wix again. Oh, wait, now we got 3 answers. What? This is very unreliable. What's up, Dave? Well, it turns out this framework is has one outstanding request. So there's no queuing. So what we were doing before was actually quite naive. For every asynchronous IM coming in, we're just spewing out read property requests, and they're kind of overwriting each other and last one wins and all that stuff. So obviously we need a queue. So I thought about, for the purpose of this demo, I was going to build a queued read property service. And I thought, no, that's not good, but let's go through the process of building one to show how you would build customized things in a command. So we got a read property queue here. Instead of doing this request, we'll just throw something on the queue. And now what's gonna pop stuff off the queue? We want some little maintenance timers. We want this command is going to be into a little mini state machine. It's got some stuff to do over time now. So we implement event listener, which if you implement that, handle event is its only event, is only method. This handle event is going to get called on every maintenance timer. And that allows us to read the queue. If there's anything in the queue, we'll fire read property request. Great. Well, that's also going to spew them real fast on every maintenance tick. So let's put some blocking in there, outstanding timer. If I've got an outstanding request, don't do anything, return from the timer tick, that kind of thing. And what about timeouts? So here you can see we're throwing a timer. And this is where I'm not trying to be teach you how to program. Obviously, I'm just introducing all the concepts that are available to you when you're writing in this framework. This is a single threaded, I'll just take a timeout here. The reason you can just freely check timers, set timers, set flags without worrying about concurrency here is because all of this stuff runs in one thread with callbacks. It's like programming in Node or JavaScript, where the entire thing, no matter how huge it is all basically one big thread with callbacks. And so the handle event is your way of you never block. Nothing here ever blocks. You do something, you get out, you return, you come back with a timer tick or some sort of event. And so that allows, it's great freedom because you're not constantly panicked about concurrency issues. Ironically, I used concurrent linked queue here because it was a simple class to use, but you don't actually need the concurrency and the synchronization and the locking. So, but anyway, if the timer expires because we didn't get an answer, then we'll say outstanding is false and we'll move on. All right, now, what about those timer ticks? Just because you're a listener doesn't mean anybody's going to send you stuff. So in our execute method, we will add maintenance to the event loop says, hey, call us on maintenance ticks. And then because we did that, introduce another concept of proper commands is that commands can be canceled. And the shell will cancel your command after 10 seconds of no activity if you just kind of don't do anything. Or you can do it yourself, or if the user gets tired of waiting, he hits enter, and this cancel method is called. So in the cancel method, we'll remove maintenance to make sure that we're not hanging out with a zombie thing listening for messages. So now, if you want to really kick it, the maintenance timer is usually like 1/10 of a second. But let's say you had a whole ton of stuff to do and you don't even want to wait 1/10 of a second for the next poll to read the next one off the queue. So you can send yourself maintenance events. So this thing says, when I get a successful read property, I'm going to send myself a maintenance event, which means I'm going to immediately look at my queue again. And obviously also when I offer something to the queue, I'm going to send myself a maintenance event that says immediately look at the queue. So this is what we've just created here is now a whole little environment here. This is a long-running state machine-oriented thing in a command that is extensively added on to the system that was not part of the built-in framework. But you can see that commands either execute and return immediately to the prompt, or they become their own little subsystem that can do whatever it wants to do. Here we have multiple registered callbacks. We have a whois client and a read property client simultaneously registered with the application layer, so that when whoises come in, we get callbacks, and when read properties come in, we get callbacks. So we've got two active things going in the application layer right now, and we've got a timer going, and we've got these event maintenance. So it's a whole little ecosystem in this one command. So that's why I went to the trouble of it dragging you through all this to introduce you how to write this command. So let's run it. And I think, let's see, yeah, this is actually, I don't know how that came, whoops, I don't know how that came across in Zip, in the Zoom, but it's really fast. That's the idea is that as these come in, because everything that comes in is kicking off another maintenance event, which is causing the poll to be read, the queue to be read again, and immediately kicking off a service, so it's as fast as it can be. It's just screaming it out. So anyway, that's it. We're done with that. Now, you notice I gave all these things names, and that's the purple stuff. And so we're going to see those names later on. So let's start using our new command. We'll go to the SCSE router, where the command is, and run Wix. And you see on the left here, we ran Wix, and there's all our answers. Look at that. We've got several are authenticated. Look at the auth on the end, because that's the point of this whole exercise, right? If you look at the auth on the end, you'll see that some of them are secure path and some of them are not, which is exactly what we would expect. But that is all from the perspective of the SCSE router. Great. But what about the perspective of device 4, way over there on the end? I want to see his view of the world as well. So let's run the Wix command over there. The Wix command is not available over there because, like hub up, hub down, we put the Wix command in the SCSE router, not in somewhere where device 4 can get to it. So what are we going to do about that? This is a useful command I want to run anywhere, but it's kind of a one-off command at the same time, right? I mean, you don't want to be editing the main core code in order to add Wix as a peer to WI. So how do we add this so everybody can use it without actually editing the core code? Because in general, everything I want to introduce to you today is how to use the platform, how to extend the platform, and all of that without actually writing any code in the code that comes in the zip file from us. Because ideally, you're not going to be wanting to merge in changes. Next time we send out a beta 3 release or final, when we send the final release, we're not planning a beta 3. But I've got some of these features will require a patch that I'll send out immediately after this. But whenever you get an update, you don't want to have to mess with it. So it's good if these are external additions, and I'll show you how to do that now. Notice it was a private command, so we don't want that. We could go over into the BACnet commands section, and right where the WI command is, we could add our WIX command. But I just said we don't want to do that because it's kind of a knockoff command. But if you did, that would apply everywhere because the BACnet commands are everybody uses those. But we don't want to do that. So, and we don't want to do it within the core code. So let's go create something called demo commands in a completely separate place. You don't even have to use the idea project for this. And I said, calm example demo is the company name. So go create something, create your own commands, add the Wix in there, implements your thing implements a command set, which will then be automatically called by the system to add these commands. Now, over in your properties file, in addition to main class, you say command class. And so now what you've done, and this is what's really cool about this, notice the blue circle says that this is test node. This came with the test kit. This is not modifying it, is not code you wrote. Test node is the standard one, but by adding demo commands to it, you now have Wix everywhere. You've added your demo commands to the test node device. So that's kind of full circle here. We've started out with using the basic commands, the basic pre-built applications that are built in. With the pre-built commands, we added a custom command through code in one of those new applications. But now we've added a custom command just by doing it externally in some editor somewhere, and then literally taking that class file and dropping it in a directory. And with text in the config properties, you've now said, hey, test node, use these commands. And now you have a global command you can use everywhere. Now, obviously, now look at the device 4 view of the world is different than the SC view of the world. The little auth tags are, as you go down the list, are different. And that's exactly what you want to see. So our mission to write an SC router and then put it in a very complicated environment with multiple hops and multiple steps, and then be able to see the auth flag, the secure path flag from each node. What does it look like? Who's, from each position in the stream, is it properly passed? Is our router working? And the smiley faces indicate that it is. So that's it. Take a breath. In the last, so we've been talking about ways of extending, and just to reiterate again, we have these built-in apps, and what we did over the last half hour is we built a new app, a new built-in app, effectively the test SC router that was missing. But that might be the last one you ever have to build when you think about it, because the toolkit has now SC to SC routers, SC to IP routers, nodes that you can create a single application that has 1,000 nodes if you want. It has basically all the pieces that you need to make that big ugly diagram with all those setups you want. And you can build your own combos like I did with the test combo, or you can just launch separate processes for all of them, as we did in this example, where we had 7 different processes nicely named. Each one has its own command window, and you can either add commands specifically to one of them or to all of them, and that's driven by the configuration property now, not by code. However, there's one more little thing I wanted to throw in, and I told Andy I'd spend about 5 minutes on this, and he doesn't even know this is coming. So,
We maybe just stop there. If I don't know what's
sure.
coming, I don't want to hear it at all. You sure want to hear this?
Well, in the last couple days, when I was doing this extensibility and making these commands, I thought, well, this is great, but as much as it's external and you can build it externally in Java and drop the class file in without changing anything in the system, I thought, wouldn't it also be nice to do a little bit play with some scripting instead of compiled Java code? Because scripts are always fun. You go over into your editor, you change it, you hit save, and immediately run it. And you edit it, save it, immediately run it. You don't launch anything. Your environment is there. All your bindings are there. This huge, complicated 7-thing thing with all these devices is all running. You don't want to take any of them down to change a command. So wouldn't it be cool if you could do some lightweight scripting with Python? And so there is now a Python command in the set of commands. You can see it right there. So let's give it a try. If you say help .py, you see you can reset the environment, you can load a script, you can run a script, or you can evaluate an expression. So evaluate an expression, great. Not these are kind of pointless, but you can see it's a Python environment that's live and dynamic. You can run little lines like this, or you can run this. Notice on the left, I simply dropped a wix.py into a script directory, and I came over here and I said py wix, and I got the same result. Actually, it's kind of funny result if you look closely at it, because I am also printing out the bindings. So never mind that. Right here, there's for every who is client, I'm actually getting a binding. So if you're eagle-eyed and you go, hey, that's not the same, no, it's not. But you can see the structure. Look, I've got a listener that's handling events. I've got who is clients. I've got read property clients. I've got everything, the timers, the listeners, the callbacks. It's all there. It's all written in Python, and you can change it over and over and over and over again and just rerun it over and over again as you want. But that's still not quite there. It's great, but what if you had over here, you've got this wix.py. What if you had 50 of these things you made? There are all these wonderful commands you wrote, these extensible commands. You wrote all these fantastic commands in Python, but there's only one command listed here. In list, it's just py. Wouldn't it be nice to write real commands in Python? Well, if you write your Python right, like here, what's on the screen, you notice I'm creating a pwix command that extends the Java class command, and it's got the exact same structure as we just saw. There's the execute, there's the cancel, adding maintenance, removing maintenance, listeners, whatever, and look, you're actually calling the same command processor add command that we did in our Java code. You're now adding this command that was built in Python to your list of commands. And if you load that script, poof, you've now made a first-class command as a peer to your Java commands. So this is all data-driven. It's all completely dynamic. You can do it on the fly with running instances. You can just say, I think I want to add a new command right now. So go make a command in Python and poke it in, load it in to the running Java instance and tweak it. And it doesn't do what you want, just edit it and run it again. It's interpreted on the fly. So, however, I finished this whole demo with this final smiley face about adding full-on first-class commands written in Python to the thing on the fly. And I thought, well, that's cool, but it's only 8 p.m. and this was last night. And so I still have a little time left. And so I went back to our SCSC application that we wrote. And you're thinking, oh no, oh yes. I wrote the entire application in Python. This should look really familiar because it's structured exactly the same as the Java application. Start, stop, close, add commands, add BACnet commands, whatever. Drop it in over here in the scripts directory, go to your configuration file, and instead of giving it a Java class, give it a script. Run it, and you've just produced an entire application of an SCSC router, which was our mission today, but I actually wrote it in Python and dynamically globbed it in to the system. So that's it. That's the end of my presentation. Thanks for playing along. I thought that was fun, and it now allows me to just I just love the ability to not have to tear down my test framework when I want to add a command. And that's what I thought was really cool about this Python thing. And it just kind of grew and grew and grew. You'll probably never do you'll probably stop at this point where you're just you're using Python to add commands or to edit them and tweak them as you go. Actually writing an entire application in Python was more of an exercise, as I said, just to prove that it could be done. But it certainly can. And so from this, you can see that basically Python is a first-class programming language for this entire toolkit. You can do anything, including the application itself. And I'm going to stop talking now.
I got to tell you, Dave, we talked about the script and the thing only a couple days ago. And
oh, I know. No, the Python, yeah, the Python subsection was put in about 3 days ago, and so yeah.
Yeah, that's pretty amazing to me. I do have a couple questions for you if you are willing to take a couple questions.
Sure. Yeah, we got 10 minutes.
So if you have both a common .main class and common main script in the properties file, which one has priority?
Oh, well, no, actually this is, they're together. The scripts is what script to run. The main class is still what's the name of the class in that script. There's no assumption that the test SC application, I hope you can see my mouse. This test SC application is just a name. It doesn't have to match the file name. So in fact, you could have multiple applications in one script file. And then so this says which script to run, and then the test SC class name is still the class within that script that is your application, but it's not a dotted Java path anymore. It's just a name.
Gotcha. Another question that came up is whether or not the logs can be viewed in Wireshark, and maybe you want to extend that a little bit into the whole conversation about Wireshark and SC.
That's a really good question. And early on, I did have a feature that spit out basically everything into some form of Wireshark. The problem is that there's no real good format for that. There's no BACnet right now. When you have BACnet IP in Wireshark, the whole IP, the Ethernet, the UDP header, the Ethernet IP and UDP headers are all there in that. Those records, the Wireshark records, are IP records. But when you're dealing with SC, the guy that decodes it inside the WebSocket, you finally get a packet inside WebSocket decoded, and I want to put it out Wireshark. I don't know all that IP wrapper stuff. I really don't know the MAC address and the IP. I mean, I could fake some of it, but the whole TLS wrapper stuff is missing. The WebSocket wrapper is missing. So I thought about making a new Wireshark format, which would just be for raw SC records. And I did that, but then writing the decoder for it became a daunting task. So the other possibility, and this is where I really look forward to like forum discussion on this, because the other possibility would be to simply make Wireshark records and lie about all those fields. The MAC address part, the IP part, the website, all the other stuff that is wrapping it, make it look like BACnet IP traffic. And so even though it's not BACnet IP, you can make it look like BACnet IP and make up Ethernet MAC addresses or whatever. And that would allow the existing Wireshark debugger, or the dissector, I guess, the right term, to view it. So yeah, I think that's a really interesting add-on project that I actually started, but just never finished because I couldn't decide which way to go. And I would really want community input as to which way that should go.
Great, thank you, thank you. Another question that came up was that SC to SC router, since you said it was kind of like a missing item, is that going to be in the final release?
Oh, yes. Yes, that'll be, I'm going to prepare a patch. I don't know whether we'll issue it as a patch or a beta 2.5. Probably should issue it as a beta 2.5, like we did with beta 1.5, because there's a couple network layer bugs that need to be fixed, and this addition of the SCSC router. So we'll probably, and the new Python command. So we'll probably issue a 2.5.
Okay, you can drop the Wix command in there too, as long as you already got it done.
Maybe the Wix command won't be a part of. It might be in a side file. I don't want to build it in.
Right. Right, but maybe as a
It was good. It was a good tutorial as it was a good example of building a command, because that was a command, as I said, it became its own little state machine. It had timer callbacks. It had multiple outstanding requests. The Wix command became valuable for demonstrating how to make a command. Not really sure it has all that much value long term.
Okay, okay. If I took these test devices and put them in a node with some third-party BACnet SC devices, where does the certificate validation happen? Is it going to do that the way it's supposed to, or what?
Say that question again, because each one of these things has its own CAs and its own validation. And of course, if things aren't validating, you can turn validation off, which is a feature of the test framework that a real device wouldn't be able to do.
Right. But in this framework, if you have we put together a set where they all have the same certificate, so they're all fine.
Oh, right.
If I drop in a new one,
mm-hmm.
then it's going to be validated, or how does that get integrated?
Oh, it's definitely validated. I mean, the fact that it's validated against the CA by default, the validation is on. So if you drop in something that doesn't have if the certificate of a third-party device, or third-party, it's second-party in this case, it's not part of the test framework. If that device doesn't match the CA that's configured in the properties file, then you'll have to configure it in the properties file, point it at a different CA list.
Okay, so the properties file is where I make that.
Oh, yes. None of that's done in code. It's all driven by the properties file. And the properties file can either point at an external file, a PEM format file, or it can contain the hex of the certificate right in there. So if for example, I anticipate that some environments, some QA environments, for example, might want to produce these properties files, configure the node instances, produce properties files programmatically. So they're going to spit out properties files, and they can either spit out files containing the keys and certificates and then make the property file point at that file. But then you got a naming, you got temporary file issues and stuff. But you could also just stick the raw data of the certificate right in the properties file itself as hex. And that's just a way of keeping it all together.
Got it. Thank you, Dave. We're about running out of time. So I want to first of all thank you for your both your explanation and your walking through it, but also the engaging way in which you did it. You even had me at the edge of my seat once or twice there, so I appreciate that. And to all of our attendees, I just want to remind you that forums, the BACnetinstitute.org, you can find answers to questions that we didn't have a chance to get to online here, as well as keep up with the release of the interim and the eventual release of the final code. We appreciate your contributions, and please give us feedback. Let us know how we can do more and do better for you. With that, let's wrap it up. Thank you all very much.